Hello and welcome to the next lecture about linked list. In this lecture, I'm going to show some examples. First of all, let's store a list of numbers. As a quick recap, we know that head is the entry point to the linked list. The head is not a node, but also it contains the address of the first node within the linked list. Each node has two items, a content and a pointer. The content contains a data field that can store any type of data as value, such as an integer, a string, and so on. The next item that a node stores is the address of the next node, namely pointer, to indicate the next node within the linked list. The node at the end of the linked list points to the null. However, if we have a circular linked list, then instead of null, there is a link between the last and the first node. But here we are talking about the most common type of linked list, which is a singly linked list. So here, the last element indicates the null. To give you a deeper understanding, let me jump into more detail. Here, the pointer of the first node has the address of the second node, and the address of the second node is mentioned below the node. The same rule applies to all nodes, meaning that each node has the address of the next node as is observed. Now it's the time to remove a node. It doesn't matter whether it is at the beginning of the linked list or at the end. Suppose we want to remove the third node. Each time we are going to remove a node, there is a general rule. Traverse to the previous node of the target node. Here, to remove the third node, we must traverse to the second node. Change its pointer to have the address of the next node of the target node. So the pointer of the second node must have the address of the first node to exclude the third node. Let's to take another example for removing. Suppose we want to remove the last node. Again, use the general rule that I described. Traverse to the node before the node we want to be removed. Here we want to remove the third node. Therefore, traverse to the second node and change its pointer to indicate the null. Simple and straightforward. Now it's the time to add some nodes. Suppose we want to add a node in the middle. Please note that the linked list does not need contiguous memory locations to store their values. So the order of the address is not important, or in other words, the addresses could be in non-sequential order since this is a linked list, not an array data structure. So let's move on. Allocate memory to determine the address of the new node. And then we must also modify the pointer of the new node to indicate the next node within the linked list. So change the pointer of the new node to have the address of its next node within the linked list. Here, because we will put the new node in the middle, then the next node is the node containing null in its pointer. Additionally, if we put the new node in the middle, then we must modify its previous node's pointer. Here, the previous node is the node containing 55 as its data value. Therefore, this node as the previous node must have the address of the new node. So the new node is added. Let's discuss another example. Suppose we want to add a node at the beginning of the linked list. Therefore, in that case, we must allocate memory, and then we must change the pointer of the new node to indicate the next node. Here, the next node is the node containing 55 as its data value. Additionally, because we want to add this new node at the beginning of the linked list, we know that we must modify the address of head. In that case, just modify the address of the head to indicate the address of the new node. That's it. I hope it was helpful and you enjoyed learning. Please feel free to ask any question, and thanks for watching this video.